Hi everyone. In this video, we are going to look at how to solve equations using multiplication principle of equality. And we have three objectives. First, we solve equations using the principle of equality by doing the same operations on both sides. This time we are using multiplication. Actually, from the last video, you know that we can do many different operations as long as we do the same operations on both sides of an equation, and the equation will stay equal. So very good. Now, second objective is that we are going to use both addition and multiplication principle. I don't know what happening here. We are going to use both addition and multiplication principles of equality. And then in the end, we are going to look at some application problems involving setting up the equation and solve it. Okay, let's look at this one by one. Basically, this principle says as long as you do the multiplication on both sides, the equation will not change. The solution will remain the same. The equation will keep equal. Just keep in mind that as long as you do the same operation on both sides of the equation, nothing going to change. You're going to be able to solve it. So let's look at our first example. 7x equals 21. We want to solve for x, so x should be on one side by itself in the end. In other words, we need to get rid of 7. How do we do that? We do the opposite operation. 7x really means 7 times x. So that's how these two are connected by multiplication in between. We want to disconnect it to get rid of 7. How do we disconnect it? We do it by doing an opposite operation. Opposite of multiplication is division. That's why we divide by 7 on both sides. We do the same operation on both sides. 7 divided by 7 is 1. 1 times x is x. That's how we get 1x. 21 divided by 7, that's 3. And you know 3 is correct answer. Moving on to the next one. This time we have exactly the same kind of problems, same structure. The only difference is that we have -6 multiplied by this unknown variable m instead of a positive number. But it really doesn't matter we have positive number or more negative number, because either way we need to get rid of this number in front of the variable. How do we do that? We do it the same way because they are connected the same way. They multiply together. We want to do division to get rid of it. So this time I divide by -6 on both sides. In other words, from these two examples, you just divide by the number multiplied by this variable, whatever that number is, and do it on both sides. So -6 divided by -6, that's 1. We get 1m. On the left-hand side, we get -5 on the other side. Positive divided by negative is negative. So that's our answer. Now, this is your first set of exercise questions. It is on the next page. And you already know if you watch my previous videos, and there's a solutions to all of the exercise questions in the video will be in the comment area below the video. Okay, let's look at our second objective, also second example. We are going to use both the addition and the multiplication principles of equality. In other words, again, as long as you do the same operation on both sides of an equation, and you will be able to solve it. Okay, and the equation will stay equal. Now, we want to have this x on one side by itself. In other words, we need to get rid of -9. We need to get rid of -2. And we always get rid of the number, pure number itself before we remove the number in front of the variable. So we do that by doing the opposite operation. You see, I can plus 9 on both sides, cancel this -9. But we learned this technique in the last video that if you don't want a term on one side, you can move it to the other side. Let's do a quick review how this works. So say we know 10 minus 2 equals 8. This is correct. Suppose I don't want to have this -2 on the left-hand side, I can move it to the other side. As long as you change the sign to the opposite sign after you move it. Say 10 equals 8, this minus become plus. Is that still true? It is still true, right? That's the only requirement. If you don't want a term, move it to the other side, just change the sign. So we do the same thing. I don't want -9 and move it to the other side. Now -2x equals 16. Now we have this structure as in example 1, right? We just divide by -2 on both sides. So x equals -8. -16 divided by -2 is -8. So we solve it. If we want to check, just replace this original x with -8. So let's check it for once. -2 times -8 minus 9. This negative times negative is positive. So that's positive 16 minus 9. The result is 7. Do we have 7 on the other side? Sure. We have 7. So this is the correct answer. Now, our second example. Basically, it's very similar structure to the first one. We don't want to have 26. We don't want to have -7. And we just want to have this x on the right-hand side by itself. So I move 26 to the other side. 12 minus 26. You can also use put 26 in the front. -26 plus 12. The result will be the same. -7x. Make sure you get -7x after you remove 26 from the right side. Now 12 minus 26, that's -14. Equals -7x. Now we can divide by -7 on both sides. So that it canceled, or x is +2. Negative divided by negative is positive, right? So we solve it. Again, if we want to check, we just put this x back in here, and if both sides are equal, that's correct answer. Now, your second set of exercise questions. Practice is super important in mathematics. This is the basic skill, basic calculations. Now, let's move on. We have our third example. What's the difference in this one? A little bit different, not too much. We have this variable terms on both sides instead of just on one side, right? That's the difference. But still, we want to have this x on one side by itself. That's why I need to move one x to the other side, one x term to the other side, so they are both on the same side. So this is what I'm going to do. I move 3x to the left-hand side. At the same time, I move this -1 to the other side, so that I separate variable and the number. So 7x minus 3x. Remember, we change the sign to the opposite when we move it to the opposite side. Equals -21 plus 1. This is the 4x. We combine like terms. And -21 plus 1 is -20. Right? Now we divide by 4 on both sides. X equals -20 divided by 4, and that is -5. Now let's double check to see if this is correct. Our answer is -5, plug in 7 times -5 minus 1. We want to see if both sides are equal or not. 3 times -5 minus 21. This is -35 minus 1 on the left-hand side. And this is -15 minus 21. Are they equal? -36 and -36. So they are equal. So we get correct answer. Our answer is -5. Now this is another set of exercise equations. Now another one. We still have variable terms on both sides, but this time we have multiple variable terms. So whenever in a single expression, you can combine like terms, always combine it, because after you combine like terms, you have a shorter equation, simpler equation to solve. Okay, 9n minus 2n, that's a 7n plus 6. On this side, positive 16 and -4, when you combine, just look at these terms one by one. Take the sign in the front as positive or negative. So 16 and -4 combined, you get positive 12. You still have positive 10n. Now, I need to bring variable terms together. I have two choices right now. I can move 10n to the left-hand side and 6 to the right-hand side, or I can move 7n to the right-hand side and 12 to the left-hand side. Either way is okay. The result will be the same. But if you don't want to work with negative numbers, you move 7n to the right-hand side. So the 10n minus 7n, you get 3n, you get a positive to work, positive number to work with. Otherwise, there's no fundamental difference. The answer will be the same, either way you do it. Okay, so I'm going to move 7n to the right-hand side, 12 to the left-hand side. So I get 6 minus 12 equals 10n minus 7n. Let's go to this side. And -6 equals 3n divided by 3 on both sides. So n equals -6 divided by 3, that is -2. So -2 is the answer. And let's move on without checking. As long as our calculation is right, the answer will be right. This is still considered to be a very simple equation. And more exercise. This is probably the last example for this objective. Now this one has parentheses. So our goal remains the same. We want to have one variable term on one side by itself. The other side is a number, so that we can divide by the number in front of the variable and get our final answer. So in order to do that, we have to get rid of these parentheses so that we can combine like terms, so that we can have only one variable term, right? So in general, when you have equation with parentheses, get rid of the parentheses by doing the distribution, okay? So that you can move terms around so that you can combine them. So let's do that. Since this is a multiplication between 2 and parentheses, this is minus, you cannot do minus before you do multiplication, right? So I'm going to do this multiplication first, which means I need to copy this 15. Now, pay attention how I do this. After you copy this 15 down here, 15 is gone. When 15 is gone, what is left? This -2 becomes -2 because there's no number in front of it anymore. This is not minus. You have to have a number in the front to be called minus, right? So now -2 times y is -2y. And -2 times -3, that's +6. Now on the other side, 6 times 2y, that's 12y. 6 times positive 5, that's positive 30. Then minus 5y. And this pretty much has similar structure as the previous, on the previous example, as in here. It's pretty much like this kind of structure. Now we can just combine like terms. So 15, positive 15, positive 6, that's positive 21, and minus 2y. Then 12y minus 5y, that's a 7y plus 30. Now I'm going to move variable terms to one side. I'm going to move this -1 to the other side so that both become positive. And at the same time, 30 to the left-hand side. Now I get 21 minus 30 equals 7y plus 2y. Change the sign to the opposite after you move a term, right? So 21 minus 30, that's -9. And 7y plus 2y, that's positive 9y. Divided by 9 on both sides, cancelled. Actually, you get 1y is y. So -1. Let's check it. This one a little bit longer. I mean, a little bit more complex, right? So our y is -1. So 15 minus 2 times -1 minus 3 on the left-hand side. On the right-hand side, let's say if they're equal, 6, 2 times -1, and plus 5, minus 5 times -1. On this side, -1 minus 3, that's -4. So 15 minus 2 times -4. And the other side, inside the parentheses, is 6. -2, this is -2, plus 5. Let's do it step by step. And then this part, after you write down this is gone. You got -5 times -1 is positive 5. Now, here, 15, you can copy 15. We do multiplication first. -2, -4, that's positive 8. On the other side, -2 plus 5, that's positive 3. So it's 3 plus 5. Now, almost there. 15 plus 8, that's 23. The other side is 18 plus 5, 23. So we get correct answer. Again, as long as your calculation is right, it will be right. Now, there's another set of exercise lessons, equations. Now, let's look at our final objectives. In this video, we're going to solve some application problems by setting up an equation first and then solve it. Okay, let's do it. Whenever we solve an application problem, it is super important that we understand the information in the description. Don't rush to the calculation, because solving problem is not about just addition, subtraction, multiplication, division. It is more about representing the information in the description correctly using an equation. Imagine if you don't fully understand the information as a result, and you set up a wrong equation, guess what? You don't need to solve it. It's already wrong. And hopefully this makes sense to you. So our goal is to understand the information and set up the correct equation. Then we do the calculation part. Okay, let's read this one. Let's read it. Juanita is driving at a rate of 59 feet per second, which is about 40 miles per hour. A sun is 177 feet ahead. how much time until she passes the sun. So it's very simple scenario. She is like 177 feet away from the sun. Her speed is 59 feet per second. They ask us how long it will take her to reach the sun. In other words, how long it will take her to drive this 177 feet of distance. So we all learned probably in elementary school, no later than middle school, that speed times time equals distance, right? Say this is her car right here, and supposedly this is the sun right here, whatever that sun is, the sun here. The distance is 177 feet, right? Distance equals speed times time. Speed times time equals distance. So we are looking for time. We don't know the time. So that's why in algebra, we can use a variable to represent the unknown. So let's use a t to represent the time. Okay. So speed times time equals distance. Now we have the equation, and this equation is correct. And we divide by 59 to get t. So t equals 177 divided by 59, and it's 3. So that's in seconds. So it will take her 3 seconds to reach the sun or to pass the sun. And that's it. And you get this exercise question here. Very similar. Yeah. And we got another one. Let me see. Yeah, we got another one. Let's read it first. The total material allotted for the construction of a metal box is 3,950 square inches. The length is to be 25 inches and the width 40 inches. Find the height. Now, pay attention to the description, not just numbers. We are given this total amount of metal for this metal box is in square inches. In other words, we are given the surface area for that box to be built. It's not a volume, okay? Surface area. So let me see if there's enough room. Yeah, so we have room on the next page. So I'm going to draw this box just to illustrate how we can set up an equation to solve it. Okay, I'm going to draw this box right here. This is not a draw to scale, okay, just an illustration. We are given length that is 25 inches. They're all in inches, so 25. And the width is 40. And we are looking for the height. So this is the height, we don't know. Let's use h to represent this height. Now, after you use a variable to represent unknown, it's time to set up the equation. Equation is nothing more than something that is factual, that is true. Okay, that's how you set up equation. And we know this number we have not used, which is the total surface area. Apparently, a box has 6 sides, right? All of the sides are identical. You have top, you have bottom, you have left side, you have right side, and you have front side and back side, right? Opposite side will have same area. So we're going to add the areas of all the 6 sides together and let it equal to this total surface area. And you know that's going to be correct equation. So let's do that. Let's look at top and bottom. So for the top and bottom, there's a rectangle. They're all rectangles. Length times width, right? Look at this area. Length is 25, width is 40. So 25 times 40. That's area of this rectangle, but we have two sides that are identical. That's why we are going to multiply by 2. So we get area of these two sides. Now let's look at the left side and right side. It is also a rectangle, right? Length is big, length like 40 and height width like this height. So really it doesn't matter whether you call it length or width or height, because rectangle, you just multiply these two adjacent sides, right? Whatever you call them, it's just the names, right? So plus 40 times h, double that, right? You have two sides. Now let's look at the front and the back. This is a rectangle we are looking at. So 25 times h, 25 times h, again, double that. And this will equal to the total surface area, 3950. So we get our equation. Now the rest, we just do the calculation to find out h. And 25 times 40, that's 1,000, because 25 times 4 is 100. 1,000 times 2, 2,000. And then 2 times 40 is 80. So 80 h. We can multiply them together because in multiplication, order doesn't make a difference. 2 times 40, 40 times 2, they are the same. You can move them around. And then the last one is 25 times 2, 50, 50h, right? 50h. Now equals 3950. And apparently this two can be combined, 130h, so 2000 plus 130h equals 3950. Now we already see this structure before. We want to have this variable term on one side by itself. So I just move this 2000 to the other side. So 130h equals 3950 minus 2000. So 3000 minus 2000, there's 1000 left, right? 130h equals 1950. Now all we need is do a division. So 1950 divided by 130. Let's see what we got. 1950 divided by 130. I got 15 inches. So the height of this box is going to be 15 inches. Now you get your last set of exercise problem, and these are 2 application questions. And that's the end of this video. You're welcome to make any comments or ask any questions in the comment area. See you in the next video.